Hello everyone. Uh, Welcome to the week 3 of problem solving session for analog communication nptel. So today we will be doing Fourier transforms. Today I am a bit sick, so I might not be fully audible. So just bear with me. If something is not understandable to you, please come back with the feed. Like, please come back in the mic and say that you have not understood. This is an interactive session. If you have any doubts, you can stop me at any time and ask me doubts. So today we will be doing Fourier transforms. We will be solving few problems based on Fourier transforms. Okay. So today's topic is Fourier transform. Okay. So we will go through the questions. Let me share my screen. Is my screen visible to all? Hello, is my screen visible? Okay, I hope so. So the Fourier trans. So the first question is find the Fourier transform for delta t, where delta t is the Dirac delta function. So this is the first question. Find the Fourier transform of delta t, where delta t is the Dirac delta function. This is very elementary. So what is the Fourier transform formula? X omega. Here it is in terms of omega or f. Okay. So this, since this the exercise is based on f, linear frequency and not angular frequency, so we will be writing the formulas in linear frequency only. So what is the formula? Xt e to the power minus j 2 pi ft dt, and this will go from all the way, entire range. And what is the, this is the Fourier transform. And just for completeness, what is the inverse Fourier transform? Inverse Fourier transform is xt is equal to, since it's linear frequency, it will be get divided by 2 pi. So 1 by 2 pi minus infinity to infinity. Xf e to the power plus j 2 pi f df. So now here xt is given to be delta t. So xf minus infinity to infinity delta t e to the power minus j 2 pi ft dt. Now delta t will only exist at delta 0, only delta 0, delta 0 tends to 1. So it will be minus infinity to infinity, rather not minus infinity to infinity, it will only be valid at one point, that is 0. It will be 0 at all other points. So it will be just be delta 0, which is 1, into e to the power j 2 pi f0 d. So 2 pi e to the power j 2 pi f0 is 1. So the answer is 1. So the correct answer is 1. 1 for all f. So the two options are 1 and 1 for all f. Since 1 for all f is more specific, so we will choose 1 for all f. So the correct answer is option D. Now, the Fourier transform of a signal xt is xf. If Fourier transform xt, if Fourier transform of xt is given by x minus f, then xt can be. Okay, so the Fourier transform of the signal xt is xf. So you are being asked what is xt if the Fourier transform of capital xt. So here there is something to consider, that small xt. Let's write here only small xt and capital xt. Small xt and capital xt are Fourier transform pairs. So small xt leads to xf, capital xf, capital xf. Now it is said that Fourier transform of capital xt. So you take the function from the Fourier transform, but you represent it in the time domain. So you just take the f, wherever there is f, you just replace by t. So you are kind of artificially taking the function to time domain. Then the Fourier transform of that, Fourier transform, then the Fourier transform of that is x of small x of minus f. Now this theorem is known as the duality property. This is known as the duality property of Fourier transform. So if capital X is the Fourier domain representation of small x, then the Fourier domain representation of capital X will be small x. So if small x in time domain and capital X in frequency domain, means capital X in time domain means small x in frequency domain. So this is duality property of Fourier transform, and it is valid for all signals that there are. So both real and complex. So the correct answer is both real and complex. This is valid for all signals. So if I wish to verify, let's say xt is given to be the Fourier transform pair of xf. This is given. Means if you take Fourier transform of xt, you will get xf. If you take inverse Fourier transform of xf, you will get xt. This is given. Now here they are saying that a capital, if you take capital xt, the Fourier transform will be small x of minus x. Yes, hello. Any doubt? Okay. So capital xt. Now let's write the Fourier transform of capital xt and verify whether that is small x minus f or not. Okay, then that will prove the duality theory. So what will be the Fourier transform of xt? So now we know xf is minus infinity to infinity xt to the power minus j 2 pi ft dt. So what will be capital xt? If xf is this, what will be capital xt? Now if you take capital xt, you have to take this variable as something different, because you are replacing the f by t. Pay attention, you are replacing the f by t. So this variable t in the first integral that is present here and here and here, this has to be represented by something else. So we can represent maybe by p for parent. So we are just changing the variables. So what have we changed? We have changed f to t and t to p. We have just changed the variables. Now using p or using f in a definite integral doesn't make any difference. So we can just replace p by f again. So it is xf e to the power minus j 2 pi 2 pi uh, f t df. Now you see that you need a inverse Fourier here. You need a inverse Fourier, right? You have, what do you have to show? That you have to show this. You have to prove this. Remember, you have to prove this. Or alternatively, you have to prove that capital Xt is the inverse Fourier transform of x minus f. So here you can see that you have got xt as some integration of xf, but it is still not inverse Fourier transform form. Why? Because this exponential is negative. In inverse Fourier transform, the exponential is positive. So you replace minus f by f. So substituting minus f by f. So here this df will become minus df, and these limits will change. So infinity will become minus infinity and negative infinity will become positive infinity. X of minus f e to the power j 2 pi ft minus df. So instead of df you will have minus df. Now use this minus df to interchange the limits here. To interchange the limits here. So you have minus infinity to infinity. So even though 1 by 2 pi is missing, but for now we will just ignore that normalizing factor and we can say that xt and x minus f are indeed Fourier transform pairs. So this proves the duality principle. Okay. Now this is done. We will move on to the next part. So this is valid for both real and complex signal. We didn't comment on the nature of the signal, so it is valid for all kinds of signal. We just proved the duality probability. If xt is an even function, which of the following statement about its Fourier transform is true? Okay, so I want you to try this. I will give you 5 minutes. Xt is even, that is xt is equal to x minus t. That you know, right? Xt is equal to x minus t. That is given. Now, what can you say about xf? Is it real? Is it imaginary? Is it both real and imaginary? That is complex. Or does it only have positive frequencies, which is a bit different from these three? So please try this, and when you are done, please open your mic and answer me. Okay, you are given 5 minutes. Please attempt this question. So if you have joined just now, please attempt question 3 on the screen. Okay, someone has messaged something. Option B. Okay. Uh, okay. So Varjot Kaur here has given the option B as answer. Anyone else having any different answer, or is it option B? If yes, then we will go to the solution directly. Does anyone have a different answer? Okay, then let's go to the solution. So the answer is option B, purely real. So you are correct, Varjot. So yeah, so it is option B. You are correct, Pratik. So option B, purely real. So how do you prove that? It's very easy, really. You have xf equal to e to the power minus xt e to the power minus j 2 pi ft dt. Now let's take let's take xt as replace t by minus t. So replace t by minus t, or it's t by minus t. Yeah. imaginary complex, or rather not replace t by minus t. Let's do this. Let's take the imaginary part of xf. So how do you take imaginary part of a complex number? By taking the that complex number, subtracting it from its conjugate, and divide it by 2j. This is how we extract a imaginary part. So if we can show this to be 0, then we have proved that xf is real. So what is xf? Xf is integration xt to the power minus j 2 pi ft dt. Now, what is its conjugate? That will be x conjugate t e to the power j 2 pi ft dt. Now, in the conjugate part, in this part, replace t by minus t ddl. Problem for that. Conjugate x conjugate t xt. Okay, yeah, understood. No problem is there. I was getting confused because of the limits. So yeah, minus infinity to infinity, like that. Now we will replace t by minus t. So if we replace t by minus t, we will have 1 by 2j minus infinity to infinity. This part remains unchanged. This part remains unchanged. So minus infinity, where did it go? E to infinity xt e to the power minus j 2 pi ft dt, like that. Now if you replace t by minus t, these limits will get changed. So this is minus infinity to infinity now. Sorry, infinity to minus infinity rather than the opposite. And now this signal x conjugate t, if you replace that, now x conjugate, this is even, means this is a real function. So x conjugate t is equal to xt. So this is a real function. So, and we also know x of minus t, since it is even, x of minus t is equal to xt. So even if you replace it by x of minus t, you will still have xt. but let's write x of minus t for now. E to the power minus j 2 pi ft dt, and then you just have dt, or rather dt you will have minus dt. So this minus will be observed in the limit, and the limit will change to 1 by 2j minus infinity to infinity x t to the power minus j 2 by ft dt minus infinity to infinity xt. Since it is even, x of minus t becomes xt, and e to the power minus j 2 pi ft dt. The minus is absorbed in changing the limits. So you see, these two terms are exactly identical. So the imaginary part is 0. This part and this part cancels. So imaginary part is 0. That is, xf is purely real. Okay, so xf is real. The correct answer is option B, xf is real. Now, in order to modify the amplitude, response and frequency domain, which of the following is to be needed to be modified in the time domain? Now, amplitude, time shift, both or none. So, if you want to change the amplitude, response and frequency domain, that is, take a sinusoid. Let's say xt is equal to a cos omega t. Let's note down the question again. In order to modify the amplitude, response and frequency domain, which of the following quantity is needed to be modified in time domain? So, let's take xt equal to a cos omega t. So, what is the frequency response? The frequency response, you can write this as a by 2 e to the power j omega t, rather omega naught. Let's write e to the power j omega naught t plus e to the power minus j omega naught t. And if you do the Fourier transform, I'm not doing that. If you do the Fourier transform, you will get xf is a by 2 delta omega plus omega naught plus delta omega minus omega naught. So the sum of two deltas. Now, I want, what is the amplitude response of xf? Amplitude response of xf. It is nothing but mod xf, which is a by 2. Rather a by root 2. Because this is also 1, this will also be 1, so it will evaluate 2. So, doesn't matter a by 2, a by root 2, it's just something proportional to a. Let's just write proportional to a. So, it only depends on a. So, if amplitude response only depends on a, amplitude, so in order to change the amplitude response, what do we need to change? We need to change the amplitude. Changing the time shift won't change the amplitude. Anyways, if you change do any kind of change in time or frequency, it doesn't change the amplitude level. Amplitude level is dependent on the voltage, the energy, the power that is there. What will change then by the time shift? The phase response, which again is not dependent on amplitude. Now, in the next question, gt is equal to sine t by t. What is the Fourier transform of gt? So gt is given to be sine t by t. What is the Fourier transform of gt? Now this question you see, this is basically the sync function in a modified way, modified sync function you can say. So this question, the integration by hand is not feasible. So what you have to do is you have to know the integral and you have to apply that result. Okay, so here this capital pi means a rectangular function. This is another way of writing rectangular or box function. Okay, so we know that and what is a box function? Xt equal to pi of t by t means it is a box function existing within minus t by 2 to t by 2. Okay, now if that is the case, it is a standard result that the Fourier transform of that will be t sync pi ft. This is the xf. Okay, so t sync pi ft will be your xf. Here this small pi is different. This is not really your rectangular function. That is the capital pi. This is just 3.14. So please mind the difference. I personally prefer to use RECT rect to not have this ambiguity. But here the question has used capital pi. So we have to use that. But please be mindful that this small pi is different from this capital pi. So this is t sync pi ft, sync pi ft. Now we have to use the duality property because we have to find the Fourier transform of sync, not the Fourier transform of box or rectangular function. So if xt is the Fourier transform pair of xf, we know then capital xf, then we know that for capital xt the Fourier transform pair will be small x of minus f. So the Fourier transform pair of t sync pi ft will be rectangular minus t by capital T. Okay, so it will be rectangular minus t by capital T. Now from this t sync pi ft you have this. Okay, so from rectangular you have a sync, and if the sync is rather not like this, the small f will get replaced by small t. So it will be something like capital T sync pi t capital T, like this. Okay, now here we will substitute capital T, substitute. Here what we have done, we have used duality property. This is your capital XF, so here we have written capital X small t. We have used duality property. Now we will substitute capital T is equal to 1 by pi. Then we will have 1 by pi sync t. So we will have 1 by pi sinc t, and the Fourier transform will be rectangular. What is t? T is 1 by pi, so it will be minus pi t. Rectangular minus pi t. So the Fourier transform pair of sinc or sin t by t is pi into, this pi is 3.14. I'm just writing 3.14 in the below line. 3.14 into rectangular minus small pi small t. Sorry, this will not be t, this will be f. It's in the frequency domain, sorry. So pi sinc pi f. Pi sinc minus pi f. That will be the answer. So, sorry, pi rectangular minus pi f. And since rectangular is an even function, so pi rectangular minus pi f is equal to pi rectangular pi f. So it is option B. The minus can be ignored because rectangular is an even function. Okay, rectangular is an even function. Now find the energy of the signal gt. Here gt is sin t by t, given in question 5. So gt is sin t by t. Now they are asking for the energy of sin t by t. But the problem is, what is energy? The general definition, first principle definition is energy of a signal x is given as the energy of a signal is given as mod xt square dt. So this is the energy. Now here we have to integrate sin square t by t square if we want to calculate the energy by first principle. Minus infinity to infinity sin square t by t square. Now this is not integrable. Using standard results, you cannot integrate this. So you cannot know the result by this method. What you have to do is, you have to use Parseval's theorem. Okay. What does Parseval's theorem say? Parseval's theorem says that the integration in the time domain will be equivalent to the integration of the Fourier domain square. So you integrate over the time domain, so Ex is equal to, by Parseval's theorem we can also integrate over the Fourier domain instead of the time domain. Now what advantage does that bring? Here in the Fourier domain you have a rectangular function which is very easily integrable. Why? Because rectangular is nothing but 1 and 0. It's just a binary function. So it only exists between t by 2 to minus t by 2. Now we have established that t is equal to 1 by pi. So it will only exist between 1 by 2 pi to minus 1 by 2 pi. So it will exist between minus 1 by 2 pi to 1 by 2 pi. So what will be the answer? The answer will be this rectangular, and what will be the value here? It will be 1. So 1 square df. So what is the answer? The answer is 1 by, so it's just f. So 1 by 2 pi minus of minus 1 by 2 pi. So 1 by pi. So the answer is 1 by pi. One by pi. Oh, sorry, there is one thing I missed. That the Fourier transform is not simply rectangular pi. It is pi rectangular pi. So there will be a pi here. This amplitude is not 1, it is pi. Why? Because if you see here, the amplitude is small pi, 3.14. The amplitude is not 1, the amplitude is 3.14. So here, instead of 1 square, you will have pi square. So you have pi square by pi. That is equal to pi. So the energy is 3.14. So the correct answer is pi. Let's take a 2-minute break. After that, we will resume our class. Okay. Uh, so let's take the rest of the questions one by one. In the seventh question, it is said that there is a signal xt given by the response here, that it is capital A for negative t and negative A for positive t. So it is like a negative signal function. Okay. So which of the following can be xt can be represented? Sorry, xt can be represented as which of the following limits? Okay. So there are three limits. We have to evaluate whether xt equal to a to minus a is represented by these limits or not. So this is more of a limit problem than a Fourier transform problem. So we will tackle one of all these limits one by one. Okay. This is more of a calculus problem actually. Okay. So our xt is a negatively scaled signal function. It is negative a for t greater than 0 and positive a for t less than 0, kind of like this. Like this. Okay, so now it said that we have to evaluate this limit and we have to find which of these limits represents this value. So first one is e to the power at u minus t minus e to the power minus at ut. E to the power at u minus t minus e to the power minus at ut. A into limit a tends to small a tends to 0. Okay. Here limit a tends to 0 e to the power 18 is 1, obviously, because a tends to 0. So this is 1 and this is also 1. So when t tends to 0 minus, that is on the left hand side, then you have a into, here you have 1 and this is 1. So a 1 into 1. So when t less than 0 it is positive a, and when t tends to 0 plus you have a 0 plus means this u of minus t, this part will go to 0, only this part will remain. So it is minus 1 into 1, so negative a. So this is one candidate. Option A is correct in representing xt. This should be it, but let's evaluate the other limits also for the peace of mind. And another is a by 2. Now in a by 2 you can directly rule out, because if you substitute 8 small a tends to 0, you will get a by 2 and negative a by 2, which are not the values here. So this is not correct. And another one is the same thing but with a plus. The same thing as a, c is same thing as a but with a plus. But if you use plus, that is limit a tends to 0 e to the power at u minus t plus e to the power minus at ut. If you take plus, you will have, when this goes to 0 and this goes to 1, you have capital A, that is a t equal to 0 plus. And when this goes to 0 and this goes to 1, that is a t equal to 0 minus, the e to the power 8 will go to 1, so this will go to 1, so it will be a. So it will be a throughout, a DC value of a, which is again not correct. So the correct answer is option A. Now comes the more relevant question, that what is the Fourier transform of this signal? Which signal? This signal. Negative scaled signal function. So what is this function? This is a negative scaled, negative. Why? Because at t less than 0 you have a positive number and at t greater than 0 you have a negative number. So it is like behaving opposite of a signal function. So it is a negative signal function. And scaled, why? Because the amplitude is not 1, it is a. So negative scaled signal function. Okay. So find the Fourier transform of a negative scaled signal function. The now we will be solving the Fourier transform here. Let's open another folder. Now, for Fourier transform, what you have? You have minus infinity to infinity xt e to the power minus j2 pi ft dt. Ah. Now you have to split this into two integrals, of course, because it is a piecewise function. So from minus infinity to 0, it is a e to the power minus j2 pi ft dt. And from 0 to infinity, it is minus a e to the power minus j2 pi ft dt. Hmm. So this will be a. What is the integration? The integration is exponential itself. By minus j2 pi f within the limits minus infinity and 0. And you have another limit minus a e to the power minus j2 pi ft within infinity and 0 by j2 pi f minus j2 pi f. Now for 0 it will be 1, that is a no-brainer. And for negative infinity you have, see, e to the power minus j2 pi f into negative infinity. Now here you have negative negative makes positive. So the dimension. Okay, this is not okay. Now here you see, when you put negative infinity, you encounter a problem. This tends to infinity. Similarly, if you put positive infinity here, you will not encounter that problem. This will tend to 0. But this tends to infinity when you put negative infinity in this one. So here you have a problem. You cannot evaluate xf like this. So you have to find another way. So what can be that another way? That is why they had those alternate representation for this negative scaled signal function. What was that alternate representation? Xt is equal to a limit a tends to 0 e to the power at ut plus e to the power, sorry, minus e to the power minus at. I think this was u of minus t and this was u of t. So I think this was the representation. Yeah, e to the power at u of minus t minus e to the power minus at u of t. Now this was the representation. So what will be xf? Xf will be, let's name this as some yt. So xf will be just a limit a tends to 0 yf. So let's evaluate yf. Yf is e to the power at u of minus t e to the power minus j 2 pi ft minus infinity to infinity dt. Now e to the power minus at u of t e to the power minus j 2 pi f t dt. Why we included these ut's are to make the divergent part redundant. That is, since this is u of minus t, it will only exist in the negative part. Only exist in the negative time part. And this one is plus, so u of t, so it will exist in the 0 to infinity. So here you see where, so it will exist only in 0 to minus infinity, and what you have, e to the power a minus j 2 pi f t dt. And here you have infinity to 0 e to the power minus a plus j 2 pi f. Now if you integrate e to the power a minus j 2 pi f t 0 to minus infinity by a minus j 2 pi f minus e to the power minus a plus j 2 pi f t a plus j 2 pi f. Here this a minus j 2 pi f, this will tend to 0, and the real part at least will tend to 0, and the time will is tending to infinity. So together they will tend to 1. So this can be proved that this tends to 1. So rather this tends to 0, sorry, this tends to 0. This negative infinity will tend to 0. Okay. Why it will tend to 0? Because you will have like this, a will uh, how to show this. When does a like an exponential tend to 0? When the base tends to negative infinity. Okay, so here since you have something a and this is going to negative infinity, so it will actually become e to the power minus infinity. So it will tend to 0. So you will have 1 by a minus j 2 pi f. Okay, and here you have negative a into t, so negative 1 into positive infinity, so again it is going to minus infinity, so again this will tend to 0. And these are anyways 0, so in the end you have, if you take the LCM, 2j 2 pi f by negative 2j 2 pi f by j sorry, this will be you have minus 1 by j 2 pi f and you have another minus 1 by j 2 pi f, so you will have minus 1 by j pi f, basically half and half you are adding. So this becomes j by pi f. So the entire limit xf becomes aj by pi f. Now you directly use formulas, but to illustrate the concept, I used first principle to derive the problem. So here you see you might have a different answer because this is in terms of omega. Omega is the angular frequency. So if they want it in terms of omega, then we have to give in terms of omega. So you have j by pi f, aj by pi f. So this is 2aj by 2 pi f. So what is 2aj by 2 pi f? 2aj by omega, because 2 pi f is omega. So if you want in terms of omega, it is 2aj by omega. 2aj by omega. This option C. Now they are saying you find the Fourier transform of ut using this xt. So you have a xt, this negative signal function. Okay. Now you want to find the Fourier transform of ut. If you directly try to find the Fourier transform of ut, you will see again you will land in the same e to the power infinity problem. The limit will diverge if you try to integrate it directly. So instead we will use this negative signal function to get ut. So this xt is what? Xt is this negative signal function a to my t less than for a for t less than 0 and minus a for t greater than 0. That is, if we write it on a board, like this. So sorry, not like this, like this. Negative for t less than 0, negative for t less than 0, positive for t greater than 0. Sorry, positive for t less than 0, negative for t greater than 0. Now we want to create ut. Ut means it only exists. Ut means it is 1 for all positive. And these are a and minus a. Now this, what is this? This is xt and this is ut. So we have to compose xt in such a way that we get ut. So minus 1 half. Yeah. So now we have to compose xt such that we get ut. So what we will do is, first we will normalize. First we will normalize xt because our amplitude is 1. So we have to get to 1 anyhow. So what we will do, we will plot xt by a. What is xt by a? It is 1 and minus 1. Now we want plus 1 in the positive quadrant. So this transforms to this. Now we will do another transformation which will convert. We will take a minus basically and we will make the 1 to plus 1 to minus 1 and minus 1 to plus 1 like this. So what is this function? Minus xt by a. Now this is 1, this is minus 1. So what do we need to do next? We have to add plus 1 to this, or plus 1 dc. If we add a plus 1 dc, this minus 1 cancels out. This one will cancel out. So you will have 0 in the negative quadrant. And in the positive half, you have plus 2. So this is 1 minus xt by a. Now how do you get ut? So ut will simply be the half of this. So ut is half of 1 minus x. That is half minus xt by 2a. Now, Fourier transform is a linear operation. So, u of f will simply be Fourier transform of half into Fourier transform of 1 minus 1 by 2a into Fourier transform of xt. Now, what is the Fourier transform of xt? We have calculated the Fourier transform of xt to be 2aj by omega. So, and what will be the Fourier transform of 1? The Fourier transform of delta t is 1. So what will be the Fourier transform of 1? By the use of delta or duality property, we can say the Fourier transform of 1 will be delta minus f. Now delta is a even function, so delta minus f is simply delta f. So the Fourier transform of 1 is delta f or delta omega. Here we are using angular frequency, so let's use omega. So delta omega. Next, okay, since we are using omega, so this will be 2 pi into delta omega, not 1, because there is a 1 by 2 pi in the inverse Fourier transform which we have to balance. So it will be 2 pi delta omega, and this one will be 2aj by omega. So let's take the half inside. It becomes pi delta omega minus j by 2 omega. Okay, so this half is not common. Sorry. So this is a, yeah. So this will be j minus j by omega, or you can write it as pi delta omega plus 1 by j omega. So this is the final answer, pi delta omega plus 1 by j omega. Option C. Now the Fourier transform of xt is given to be capital Xf. So what is the Fourier transform of xt to the power j2 by f naught? So in the 10th question, the Fourier transform. Okay, you can try this if anyone is there. Is anyone there in the meeting? Okay, yeah, you are there. Please try this. Take 5 minutes. Please try this. This is very easy. I think you should be able to do this. Please try question number 10. Take 5 minutes. Okay. So option A. Uh, did you not understand any question? I haven't seen that message. Could you get that, Varjot? Varjot, please open your mic. Hello. Okay, you later on understood. And for this current question, you are saying option A. Okay. 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 Fine. So the answer is indeed A. Very good. So the answer is A. So what you do is you simply directly use the expression xt to the power j2 pi f naught t. You have understood, but for the record I have to solve this. So I will just solve this. Bear with me. So Fourier transform of xt to the power j2 pi f naught t. So you just put here xt e to the power j2 pi f naught t e to the power minus j2 pi f t dt. So this is xt. So if this is xf, let's write this is xf. Xf is xt e to the power j 2 pi minus e to the power minus j 2 pi f minus f t dt. So this will just, so like this is not xf, sorry, this is not xf, this is something else. So here you can see if xf is this one, xt e to the power minus j 2 pi ft dt. So what is this? This is just xf minus f naught by comparison. Just you are replacing f by f minus f naught, and f is anyways not the variable of integration, so you can just simply replace it in the place where it is occurring, and the rest of the integral will remain unchanged. So you will have xf minus f naught. So this is x f minus. Okay. Now, if this is done, then I think we'll go to the next question. Oh, okay. There are no more questions. So today's topic ends here. Yeah. So, do you have any doubts? You can ask, or else this meeting is over. You may leave. If you don't have any doubts, you may leave the meeting. If you have any doubts, you can ask directly regarding this session or any other session. Any doubts? Okay. Okay. Then the meeting is over. Thank you. It was about. Yeah, you are saying something. It was about study material. Okay. Yeah, go ahead. Ask your doubt. Please open your mic and ask, because this is an interactive session. So please open your mic and ask. हेलो, हाँ पूछो, क्या क्या जवाब? अच्छा, ठीक है, फिर भी माइक खोल के बोलो. आई विल ट्राई टू अंडरस्टैंड. माइक खोल के बोलो. हाँ बोलो. हाँ बोलो बोलो. हेलो.
I'm audible. Hello.
हेलो, हाँ बोलो.
Hello.
हेलो, हाँ बोलो बोलो. सुनाई दे रहा है.
जी मैं ये पूछ रही थी कि अभी तक हेलो.
हेलो, हाँ सुनाई दे रहा है. यू आर ऑडिबल. प्लीज गो अहेड.
ओके. मैं पूछ रही थी कि अभी तक मैंने रजिस्ट्रेशन नहीं की, तो अब ऐसे 3 तक है ना डेट.
कुछ समझ नहीं आ रहा है. ओके फाइन. यू जस्ट राइट इन द मैसेज. ओके, राइट योर डाउट. ओके, रजिस्ट्रेशन फॉर एग्जाम. ओके, मैं देख के बताता हूँ. अभी देख के बताता हूँ. एग्जाम रजिस्ट्रेशन एंड्स बाय 15th अगस्त. ठीक है, 15 अगस्त इंडिपेंडेंस डे के दिन. दैट्स द लास्ट डेट. डू योर एग्जाम रजिस्ट्रेशन बिफोर 15th अगस्त. ओके. Any more doubt? Huh. What about study material? Hmm. What about the study material? Uh, okay, yeah. Is it available on the website? Fine. So the study material is basically you have a transcript for the videos that are there. सर का जो वीडियो है उसका ट्रांसक्रिप्ट है और उसके सिवाय तुम्हारा ये जो मैं जो पढ़ा रहा हूँ ये क्वेश्चंस एंड आंसर्स ये तुम प्रॉब्लम सॉल्विंग सेशंस के जो पेज है उसमें तुम्हें मिल जाएगा. मैं जो पढ़ा रहा हूँ उसका असाइनमेंट का पीडीएफ वीक बाय वीक जैसे पढ़ाऊंगा 1-2 डेज के अंदर उसका पीडीएफ अवेलेबल हो जाएगा. एंड उसके सिवाय द बुक्स आर सजेस्टेड बीपी लाठी and BP Lathi and another book is there I think Hekin. Yeah, BP Lathi and Hekin. तो यही स्टडी मटेरियल है इसके सिवाय और कोई स्टडी मटेरियल नहीं है. सो द क्वेश्चंस आई टीच वो ड्राइव में अपलोड होता है एंड उसका लिंक तुम्हें आई थिंक है प्रॉब्लम सॉल्विंग सेशन के टैब में जाओगे तो मिल जाएगा. और उसके सिवाय बीपी लाठी हेकिन का बुक एंड उसके सिवाय वीडियोस का ट्रांसक्रिप्ट और कोई मटेरियल नहीं है. दीज आर द ओनली मटेरियल्स. बुक्स अवेलेबल ऑनलाइन देखो पीडीएफ अवेलेबल हो जाता है. यू हैव टू सर्च इन गूगल. तो वो क्योंकि वो पीडीएफ मोस्टली क्या होता है ना इलीगल डाउनलोड होते हैं. तो एनपीटीएल तो गवर्नमेंट का साइट है ना उधर हम अपलोड नहीं कर सकते पीडीएफ उसका. तो यू कैन सर्च इन द इंटरनेट प्रोबेबली पीडीएफ मिल जाएगा. लाठी का तो मिल जाएगा हेकिन का भी शायद मिल जाएगा. ठीक. ओके. थैंक यू हैव अ नाइस डे.